Being able to determine the difference between independent and dependent variables is extremely important in math, especially once we start to look at some graphs of these situations. So the difference between the two, the easiest way to think about it is the independent basically acts alone. It's really not affected by anything else. Whereas the dependent depends on the independent. So the dependent, that makes sense, it depends on the independent. So it gets affected by the independent. So let's try to look at some situations where we need to decide which is the independent and which is the dependent. So for example, it says the temperature of a pot of water as it is heated. Well, I have to think about the two variables here. For the one, I think most of us can realize that temperature is one of the variables. So temp. Okay, before I decide whether that's the independent or dependent, I have to come up with what the other variable is. Well, I have water, I have heat. Which one would be the other variable? Well, you have to think about, what am I doing? I can increase and decrease things. That's what I'm thinking about with variables. So the temperature can increase or decrease, right? Can the amount of water increase or decrease in this situation? No, it just says of a pot of water. Could the heat increase or decrease? Yeah, it says as it's heated. So the heat is the other variable, right? Because it's increasing or decreasing. Now I got to decide, does the temperature depend on the heat, or does the heat depend on the temperature? Well, I would think that the temperature would increase as it gets heated, so the temperature depends on the heat. So the temperature would be the dependent, whereas the heat would be the independent. Okay, so the heat isn't affected by anything, it acts alone, whereas the temperature depends on the heat, right? The less it's heated, the less the temperature, the more it's heated, the higher the temperature. So you got to decide which one depends on the other. Sometimes it's hard to see which variables you're using as well. Like this next guy, you and your friends decide to buy pizza. You notice that as the number of people deciding to help pitch in money for the pizza increases, the less it costs per person. Okay, so what are my two variables? Well, I have something increasing here, right? What was it? The number of people increasing. So number of people is one of my variables. And what's my other variable? Let's see, there's money, there's pizza. Is the pizza increasing or decreasing? No, it says number of people increases, that pitches in, the less it costs per person. So here's my other variable, the less it costs per person. So that would be the cost per person. So you might think pizza, but you're really not increasing the number of pizzas and decreasing the number of pizzas. You're looking at the number of people. As that increases, the less it costs per person. So which one depends on the other? Well, let's see. Does the number of people depend on how much it costs per person, or does how much it costs per person depend on the number of people? Now, maybe I'll say that again. Does the number of people depend on the cost per person? No, my number of people doesn't get affected by the cost, but that doesn't come into play first. I got to know how many people first before I know the cost. So the cost depends on the number of people. So the cost per person would be the dependent because it depends on the number of people, whereas the number of people would be the independent. So I'm just going to label I and D for those. And let's do one more. The number of cars passing a toll booth and the amount of money made at a toll booth. Well, this one that gives it to you. The number of cars passing through the toll booth is one variable, and the other one is the money made. So which one depends on the other? Do the cars depend on the money made, or does the money made depend on the number of cars? Well, hopefully we can realize the money depends on how many cars. So the money should be the dependent, whereas the cars would be the independent. Okay, so you can never get enough practice at something like this. So let's just do a few more. I'm going to go through these pretty quickly. So independent, right, it's on its own. The dependent depends on the independent. Your brother forgot to put the milk back in the refrigerator after breakfast, so it was warm by the time he got home from school. So what are my two variables? We got the temp of the milk, and what's my other variable? This is kind of the tricky one. Is there something about schools? Is something about breakfast? Well, the temp of the milk gets warmer as what goes by, as more time goes by. So time and the temp of the milk would be my two variables. So it's kind of tricky to think through what are the two variables, first of all. Well, which one depends on the other? Yeah, the temp of the milk depends on the time, right? Because the more time, then the warmer the milk, the higher increase of the temp of the milk. What about this? You measure the height of a plant every week for 10 weeks. So you got time again, and you got the height of the plant. Well, which one depends on the other? Yeah, the height depends on the time. How long you let it grow for. What about 3? You notice that adding extra chocolate chips to your batch of cookies makes them taste better. So the number of chocolate chips is one variable. The other one would be the taste. So the more chocolate chips, the better it tastes. So which one depends on the other? Yeah, the taste depends on the number of chocolate chips. Good. So if you're still having some trouble, maybe pause your video. Try to attempt these guys right here. Which one's the independent and which one's the dependent. And then play your video, and I'll have these all filled out for you. We'll just stop to the first 9 there. The one thing to make note of is that the independent variable always goes on the x-axis. Okay, that's super important. Independent variable goes on the x-axis, where the y-axis will always have the dependent variable. Okay, so remember that. Independent goes on the x-axis. All right, some vocab. Continuous. Continuous just means our graph just keeps going, and there's no breaks in it. Okay, so for example, something like this, that's continuous. It just keeps going. Discrete means it's got a bunch of points. So discrete, think of a bunch of points. So that's looking more like here, 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 here. Okay, it's discrete. It's broken up. It's not continuous. It ends and starts and stops and all kinds of things. Increasing, well, you could have a straight line. You know, that's increasing. You could have a curved line that's increasing rapidly. You could have a curved line that's increasing slowly. Okay, lots of different things. Decreasing, same thing. I could have a straight line. I could have it decreasing more quickly, or I could have it decreasing more slowly. Lots of different things with curves. Linear, nonlinear, well, linear is a straight line, whether it's increasing or decreasing. Nonlinear, any type of curve to it would be nonlinear. So let's make a graph that's increasing, linear, and discrete. So discrete means I need points. Linear means they need to be in a line, and they got to go up, increasing. So if I put a point here and put a point here, all my points just have to make a straight line if I were to connect them. But I'm not going to because it's discrete, so I could leave it just like that. How about a nonlinear graph that is decreasing, then increasing? Okay, so I can start wherever. It decreases and then increases. And it's nonlinear. It doesn't state if it needs to be continuous or discrete, so I just made it continuous. Now let's use our independent and dependent and make a graph for that situation. So it says the temp of a pot of water as it's heated. Well, we already described that the temp depends on the heat, how much it's heated. So the heat is the independent. So this is, the independent is the heat, how much it's heated, and the temperature is the dependent. So basically, as I increase how much it's heated, what is happening to our temperature? Well, our temperature, it might not be at 0 degrees here. It might be somewhere in here. So as it gets heated, it's going to get a higher and higher and higher temp, just like that. Okay, so the more heat that's applied, the hotter it gets. So that would be continuous, right? And it would increase more rapidly. The more heat, it's going to get hotter and hotter. Could you say that you have a straight line? Yeah, I suppose, it depends on how much heat is applied and how fast. So you could have had something more like this, I guess, but it just depends. If I would, turn my burners up to high right away, I would assume that I would use a graph that looks like this. If I just slowly heated it up a little bit at a time, then I would say it maybe might more so be like that. Okay, so either way would probably work in that situation. What about the pizza situation? Okay, we decided that how much it costs per person depends on the number of people, which is the independent. So I'm going to put number of people down here on the x-axis because the independent always goes there. Number of people. And we got the cost per person over here. So if there's not anybody buying, if there's only one person buying the pizza, would it cost more or less? Yeah, it's going to cost more. So the smaller amount of people, the more it costs, and the more people that come into play, the less it's going to cost. Would this be a curved line or would it be more straight? Yeah, I think it would be a linear relationship, right? Each person that comes into play is going to drop at a certain price each time. So it's going to cost a lot if there's nobody in the situation, and it's going to keep coming down until it costs a lot less like that. So it might be helpful to think about, okay, the number of people as that increases, what would happen to the cost per person? It's going to decrease. So that should go opposite. It should be like a negative slope or a negative. What about describing domain and range? We've done this already. So domain are what? Are those our x's or our y's? Yeah, those are our x values. So because d comes before r, x comes before y. So domain are the x's. So what I want to do is, if it's continuous like this, remember we want to make an inequality with x in it. So I got to think, what's the smallest x that I used? Well, when x is 0, right? What's the biggest x I use? When x is 9. So I'm going from 0 to 9. So we'll say 0. We're including 0, so I say less than or equal to x, which is less than or equal to 9. So that means I'm using all x values that are between 0 and 9, right? We use that compound inequality. And then I'll do the same thing for the range, for the y's. So what's the smallest y that I use? Well, right here, 1, when y is 1. So I'm going to say 1 is less than or equal to, what's the biggest y I use? Well, when y is 10, right? It gets all the way up to 10, so I'll say 1 is less than or equal to y, which is less than or equal to 10, right? So if I plug in a number like 5 for y, it should make sense. It's in between 1 and 10, just like that. Okay, so this would be my domain and range. So if it's continuous, we should have inequalities, a compound inequality.